Properties of exponents. The properties of exponents follow directly from expanding them to look at the repeated multiplication they represent. Don't memorize properties, just work to understand the process by which we find these properties, and if you can't recall what to do, just repeat these steps to confirm the property. So we'll use 3 as the base in our examples, but the properties hold for any base. We show that with the base of a and the powers b and c as we move past that example of 3. So here's a couple of facts that we're going to use. Again, that definition of exponents, where we have in the first line here, we have 3 to the second power is equal to 3 times 3. It's that base of 3 multiplied twice. 3 to the third power is 3 times 3 times 3. It's that base of 3 multiplied 3 times. And 3 to the fifth is 3 multiplied 5 times. 3 times 3 times 3 times 3 times 3. Again, we have a base of 3, and here it's being raised to different exponents, so that's just showing you how many times you need to multiply that base of 3. So we need to develop all the properties of exponents so we can discover one of the inverse operations of raising a number to a power, which is actually finding the root of a number to that power. But that will emerge from the final property that we'll explore. But getting to that property requires understanding the other ones first. Again, we're starting off small and building up, and again, that will be our goal, to look at finding the root of a number by using properties of raising a number to a power. So the first thing we're going to look at, the first property, is that when multiplying numbers with the same base, we add the exponents. That's the first property we're exploring. And with variables, with any base raised to any exponent, that would look like a to the b times a to the c is going to be that same base of a with our adding the exponents, the sum of the exponents, so a to the b plus c. Now, if we use our example just to show this holds true with a base of 3, we have 3 to the second times 3 to the third, we're claiming is equal to 3 to the fifth from the 2 plus 3. Well, if we expand 3 to the second, that would be 3 times 3. And if we expand 3 to the third, that'll be 3 times 3 times 3. And now, because multiplication, we don't have to group them separately, we can group them all together. We have that 3 to the second, 2 3's multiplied, and 3 3's multiplied, all together actually gives you the 5 3's. It's 3 multiplied 5 times, which is 3 to the fifth. So it holds true that 3 to the second times 3 to the third is going to equal 3 to the 2 plus 3. You can add the exponents, which gave us that 3 to the fifth. So again, any base a raised to any exponent b or c, if we multiply those terms, those expressions, you'll get a to the b plus c. When multiplying numbers with the same base, add the exponents. Now, when dividing numbers with the same base, we want to subtract the exponent of the denominator from that of the numerator. This is our second property. Almost the opposite. We dealt with multiplying with exponents. Now this is dividing with exponents. So we have any base a raised to the exponent of b divided by that same base of a raised to the exponent of c equals a to the b minus c. We're subtracting those exponents. So here in our example, we have 3 to the third divided by 3 to the second. We can subtract 3 minus 2 to give us 3 to the first. Now this holds true again if we expand. 3 to the third is 3 multiplied 3 times. 3 to the second is 3 multiplied 2 times. And we have our 3 over 3's, which simplifies to 1, or reduces to a factor of 1, so we don't have to write it. It cancels out. It goes away, leaving us with just that 1 3, which is 3 to the first, or 3. So this does confirm that when we divided those two expressions that had the same base of 3, we could just subtract the exponents. 3 to the third divided by 3 to the second is equal to 3 to the 3 minus 2, which is just 3 to the first. Again, reinforcing, When dividing numbers with the same base, subtract the exponent of the denominator from that of the numerator.